Today, operating a transit system that's profitable means that all operating and capital costs are covered by the fare charged to those who use it. Many years ago, that was possible, but not today. This chart shows the subsidy amounts our local, state, and federal government provides to a few of America's transit operators to run what many believe are subpar transit systems. However, the dependency on government funding is not the only problem with America's transit systems, it's just the one most talked about. You could double or triple the subsidy funding amounts, and the two biggest problems would remain for every transit system in America. The first is, transit systems are slow, much slower than cars, and the second is, transit systems don't go where you want to go. So how do we fix these two problems and the many others that today's transit systems have? I think we can all agree that a heavy dose of innovation is needed. Developing solutions to the complexity of America's transit systems will require the special kind of innovation that Peter Drucker defined as systematic innovation, which is the purposeful and organized search for changes, and in the systematic analysis of the opportunities such changes might offer for economic or social innovation. So, let's start with this preliminary assessment and see where this leads and how much of America's transit problem we can solve. This is a diagram that deconstructs a transit system into many cause and effect linkages to illustrate the importance of vehicle design and its influence in meeting passenger requirements. There are many issues not shown on this diagram, but it's a start to a more formal and comprehensive statement of the problem and what the needs are, which will be performed in the next phase of the project, which is the advanced concept development phase. So for this project, the customer is the commuter that dreads the daily commute in their car from the suburbs to an urban office center, and it's also the Americans who are unable to afford the housing available within the typical commute parameters of distance, time, and cost to commute. A fast, affordable, new way to commute is needed that would change the commute calculus that Americans use today. In America, living farther out has always been an option, and one way that made the American dream of home ownership possible. Today, making it more possible to more Americans, especially Gen Z Americans, would be one more way to make America great again. So, these are the most basic set of requirements of the ultra-speed commuter rail system. This system will reduce commuter time, increase access to more affordable housing, reduce traffic congestion and carbon emissions, and make travel to and from America's urban office centers a stress-free and enjoyable ride. The operational requirements will be met using a single, 57-passenger, autonomous, ultra-speed vehicle with a design very similar to an aircraft, which should not be surprising. Since the performance requirement is very high top speed and high acceleration, which requires that the vehicle be as light and aerodynamic as possible. All passengers will be seated. These vehicles will operate on a dedicated elevated railway that will be constructed mostly along existing highways and will interface with existing metro rail systems at each of their terminus stations. The target fare for passengers is 10 cents per mile, which matches what many Americans pay for gasoline when traveling to work in their cars. The goal is to match or beat door-to-door travel time, which will include the travel time of legacy systems. Using a single, autonomous vehicle will allow the transit operator to adapt to the demand throughout the day and not be bound to a fixed, inefficient schedule and waste of resources. This will also enable no-wait passenger transfers to legacy systems. Range extensions to existing metro commuter systems of 100-plus miles and ultra-speed metro rings will be possible. Eliminating long, multi-vehicle train sets will also reduce terminal sizes and enable free covered parking for park and ride commuters. So what does this vehicle look like? This is the side view of our 80-foot-long ultra-speed commuter rail vehicle sitting just a few inches above the top of the rail. Passenger windows are kept small like in an aircraft for economic, aerodynamic, and aesthetic purposes. This is a summary of the physical characteristics that states the gross vehicle weight at 50,000 pounds. This is probably a very high estimate, but one that is used in all of the dynamic performance models that provide estimates of acceleration, top speed, and energy consumption. The frontal area is estimated at 65 square feet, which is a key factor in reducing aerodynamic drag, which is the dominant resistive force at high speed. The ultra-speed commuter rail vehicle will have an electric motor at each wheel, providing a total of 3,000 horsepower. It will have a top speed of 320 miles per hour and will accelerate to 250 miles per hour in 96 seconds. A 500 kilowatt-hour battery provides a 98-mile range at 250 miles per hour. Don't be surprised to see this vehicle easily break the rail speed record of 357 miles per hour that our friends in France set in 2007, or even the 375 miles per hour maglev record set in Japan in 2015. The second part of the development of the ultra-speed commuter rail system is the validation of the dynamic and economic performance of the prototype systems in a real-world environment. Information from the demonstration will be used in feasibility studies by other metro commuter systems like the one in Dallas or Denver, New York City, New Jersey, BART, in the San Francisco Bay, or Atlanta, which is the best place for our demonstration, especially since the development will take place in Cobb County. The 5 red dots depict the endpoints of MARTA which we will connect to. These are the places where passengers will change modes between MARTA and the new MARTA extender system, which will be owned and operated by a separate corporate entity. The MARTA extender will effectively add an additional 28 counties to the 11-county Atlanta metro area and add a population of 1.8 million. Improving mobility will greatly enhance employment opportunities for Georgians in or near this new supermetro region, which will improve every employer's quantity and quality of job candidates. The demo has 10 commuter lines extending to the towns represented by blue circles on the map. For example, the Forsyth Terminal Station located on I-75 at exit 193 is 55 miles from the MARTA end point at the Hartsfield-Jackson Airport. This is a better view of the candidate locations of the Ultra Rail stations. This is a straw man proposal that is open to input from all stakeholders, which means everyone in Georgia. For example, it is most likely that the Forsyth line will be extended to Macon and Warner Robins with a Macon terminal on I-475 and a Warner Robins terminal on I-75. By the way, an express service with no stops to the airport would take 26 minutes from Warner Robins and would be a great enhancement to Robins Air Force Base, especially quality of life. The MARTA extender, ultra-speed commuter rail lines consist of 43 miles of trunk lines and 428 miles of branch lines. That's a system total of 471 miles. Trip speeds from MARTA extender end-of-line terminals to MARTA destination stations will average between 95 and 134 miles per hour. That assumes an average cruise speed of 200 miles per hour and a 3-minute loss for each station stop. This is clearly faster than driving a car, even without traffic congestion. The MARTA extender will more than double the commute range and mobility of the 7 million residents of the Atlanta Metro and MARTA Extender region, which will greatly increase the diversity and quantity of employment and home ownership options to levels unmatched in America. Check this out. Many people have discussed the need for an Atlanta metro ring or outer perimeter highway around Atlanta, 20 to 25 miles outside of I-285. This is an illustration of a 400-mile ultra-speed commuter rail ring that would greatly enhance mobility in the Atlanta metro area and decrease the need to travel through Atlanta or even use I-285. Let me add a bit of economic information on the Warner Robins Airport Express idea. The economic case for a 98-mile Warner Robins non-stop express to the Atlanta airport assumes a fully loaded vehicle traveling at 200 miles per hour. The cost for electrical energy at 10 cents per kilowatt hour is $35, which is 61 cents per passenger. Our goal for a passenger fare is a maximum of 10 cents per mile, which makes the fare $9.80. At this rate, fare recovery for capital and operating costs should not be a problem. Of course, that's a point that must be proven by the demonstration. One more thing, it's easy to imagine 20 or 30 ultra-speed rail vehicles carrying Middle Georgia football fans to an Atlanta Falcons game on Sunday, or to a Georgia football game in Athens on Saturday. This is truly 21st century stuff, and why shouldn't Georgia be the first to do it? So where do we start, and how do we make this happen? First, this project is one of 3 joint venture projects proposed by MEL and NextGen Systems as Transportation 2.0 projects. Each project has a draft concept of operation and ready for the next step. The next step is the Advanced Concept Development Phase, which will be funded by the Advanced Transportation Projects Corporation. This phase will include a more formal, systematic, and in-depth operational and technical analysis of the problem and the proposed solution. It will also include analysis of capability gaps, developing economic models, conducting market surveys, and developing a more detailed concept of operation. Several critical item demonstrations will also be performed to mitigate cost, schedule, and performance risks. A key part of this warp speed development project is the need to establish an open innovation platform. This platform will be a physical place for the co-location of all project collaborators, stakeholders, and developers. Completion of the system. Performance specification is the key predecessor event to the award of a contract for system development. The development contract will include the design and construction of an elevated ultra-speed vehicle test track and 2 stations which will be used to demonstrate full compliance with the performance specification. A contract for an operational demonstration will be awarded when all performance requirements have been successfully demonstrated. The operational demonstration will require construction of elevated rail lines, passenger stations, maintenance facilities, vehicle garages, and manufacture of limited production vehicles and other systems required for operation of the MARTA Extender ultra-speed commuter rail system. Here's my last slide. So what's the payoff? It's better jobs, better employees, affordable housing, an economic boost to downtown businesses and real estate, improved quality of life, lower cost of transportation, and a decrease in highway congestion, and it also might be the very thing we need to stop 80 years of sprawl, not just in Atlanta, but all over America. How about that for a payoff? That's all for now. Thanks for watching.